So today we're going to start off with Unit 1, Lesson 1. This is a little bit of a warm-up. This isn't part of the big lesson, but this is part of your notes, okay? So what we're going to do here is you guys are going to follow along with a presentation. We're going to be talking about shapes and scaling. The first thing we need to do is you guys are going to do this as individuals. You're going to look at this. I'm going to give you 30 seconds, and you're going to think to yourself which one of these four does not belong and why. I'm going to tell you right now, there is no right or wrong answer. There's arguments for all of them, but you as an individual choose. So 30 seconds, look at them and tell me or decide which one does not belong. Thumbs up when you've made your decision and you have your reasoning. Keep them up high so I know. Oh, so now people are putting them up. Some of you guys need more time. You got to make a decision. Remember, there's no right or wrong answer. You just have to make sure that you pick one of them. Mishti, I also need you to sit up because otherwise I have to buy you baby food. If you guys sit in the tall tables and you guys sit like it's a high chair, I will bring you Gerber. Okay, now discuss with your groups which one doesn't belong and why. Go. Okay, finish up your discussions in 10 seconds.
They all have the same patch besides B.
Okay, do I have a volunteer? Remember, participation is part of your grade. Do I have a volunteer to tell me which one they think doesn't belong and why?
I think B because every other one has an order, but that one's different.
What do you mean different? Expand.
A is close. Or no.
No, continue. Continue. Well, why did you pick B originally?
Because it's different.
How different is it? What do you mean different?
Because most of the red on the other ones are close to the purple, but that one's not.
Okay. You.
I think it's B because all the other ones are even, and that one has a slightly less shape.
What do you mean even?
Like they're all even shaped. They have shapes in them that are all the same shape.
Okay, instead of using the word even, what other word can we use? I understand what you're saying, but we're equal. Okay, this is your first vocab word that's going to be put in your notes. Okay. Yes, no, don't write down yet because you guys don't even know what you guys are writing down yet. Instead of equal, mathematicians use a certain word. I know you guys probably haven't been taught this yet because the other two classes didn't know it. Begins with a C. The C makes a K sound. What word is that? When they're equal, when they're the same, they are what? Last year they didn't teach you guys this word? Give you a hint. Begins with a C. The next letter is O. Next letter is N. Oh, that made your hand go down real fast. Okay. Your first vocab word. Ladies and gentlemen, can we say that word? This is congruent. For something to be congruent, it means it's equal, the same, has something the same. So, for example, when we look at these shapes, A has all of these shapes that are exactly the same, right? If I were to cut these out and stack them up nicely, twist them so they're all going the same way, they would all be exactly the same shape, right? They are congruent. These two, even though there's only two of them, which we'll get to later because somebody's going to argue, and this one doesn't belong, there's only two shapes, but are those two shapes equal? If I were to cut them and put them together on the same angle, they would be the same, so they are, ladies and gentlemen, what's the word? Congruent. Even this weird hook shape, all of these, if I were to cut these out, they would all be facing the same way. They are all congruent. This one's the only one that doesn't have equal shapes. I'm going to use the purple one and the red one as examples. That purple one's way wider than the red one is, right? So they're not the same shape. They are not congruent. Going back to the term congruent, congruent does not only mean that they have to be the same. When you guys draw like a stick figure house, what shapes do you guys usually use? What are the two shapes, ladies and gentlemen? Square is one of them, and the other one is a? So, I'll give you guys an example. Here's a little stick figure house. You may want to add these to your notes. Nope, that didn't equal out. Let me do this again. Nope, definitely not happening. Better. Pretend that the triangle actually matches the square, because I can't get it to be congruent myself. Let me try one last time. Please work. That's as good as it's going to get. Okay, are the two shapes congruent? Meaning, are they the same? No, they are not. One's a triangle, one's a square. What do they have together that is the same? And I'll give you a hint. I was working on it just now. This shared side. For the triangle to fit perfectly on the square, the side of that triangle and the side of that square should be the same, right? The same length. Which another way of saying it is that side is congruent. So there's congruent. So again, congruent means equal, the same, or has something that is the same. For a square, all four sides are equal, right? That means all four sides are congruent. Okay? So going back to our example here, every example A, example C, example D, all have congruent shapes except for B. B, those shapes are not congruent, which means they are not equal. Okay? Argument C, you guys have said there's only two shapes. That's basically the argument. And then argument D is that it is a weird polygon, but it is not a normal shape, right? When we talk normal shapes, we mean squares, rectangles, triangles, circles, things like that. This is a weird polygon. This probably is the reason why it doesn't belong. Another reason A doesn't belong, it's the only one that's not made up of what type of shape, ladies and gentlemen? Now, is D made of triangles? But it's triangular, right? So again, we got to learn those words that we can use. These are all triangles. Those two are triangles. This shape is triangular. It's not a triangle because that weird hook thing. So A would be the only one that does not have triangular shapes. A also has one other thing about their shapes. And look what I'm pointing at. What am I hinting at right now? Not the color. Say it out loud. I'm talking about the angles, right? We know what a right angle is, right? 90-degree angle. If I were to grab a piece of paper and put it in that corner, it would fit perfectly. A is the only one whose shapes are all made of 90-degree angles. Technically, maybe C has 90 degrees on both, but every side is not a 90-degree angle, right? If I look at this 90-degree angle right here, 90 degrees, 90 degrees, 90 degrees, 90 degrees. That's the same for all of them. So A is the only shape that is made up of 90-degree angles. Or you can even argue the only one that has straight lines that are not diagonal, right? Because they're all technically made of straight lines, but this one's made up of weird straight lines. These are all diagonal. This one just straight, left, right, up, down. So either one of these doesn't belong. There's no right or wrong answer. Now, we're going to be talking about different kinds of shapes. And you guys are going to be doing this in your notes. But if you open up your workbook to page 6, you will see what I am talking about. And unfortunately, on YouTube, for those of you guys that are watching this, hopefully you have your workbook. For those that don't have their workbook, I'll actually draw it here. Just thought of that. So in your workbook, you have a challenge on page 6. in your workbook. There is page 6. So, you are going to make a triangle made of triangles. You're also going to make a rhombus. So again, this shape here in blue is a rhombus. Think of it like almost a diamond kind of shape. Like they took a square and they pulled diagonal corners and they stretched it weird. So there's a rhombus. And then you have a trapezoid. Now remember, trapezoids can look like this. That's a rectangle. Trapezoids can look like that, right? But the version they want you to use is the classic version. They want you to make 2 different trapezoids using just trapezoids. Now, they don't tell you how many to use. So what I would suggest is draw big of that shape and see how if you can dissect it into smaller of those shapes. So with your group, I'm going to answer this phone in a second. Build these shapes just using the same shapes. Go. 1. Okay. Do I have a volunteer either to come up and draw or to explain how to draw? We're going to start with a triangle one first. So do I have a volunteer to come up and draw a triangle made of triangles, or do I have somebody that wants to explain it to me? You're going to come draw it?
Yeah.
Okay, be aware the microphone will be right there.
Okay.
Also be aware that this is a weird, so like if you draw a shape, it auto-corrects it. So just a heads up.
Okay. What the?
Yeah. There you go.
Wait, hold up. I'm gonna redo it.
Okay.
Wait, I forgot.
Go bring your notebook. Hang on, give her a shot. She's going to bring her notebook up.
Yeah.
There you go. So, we have a triangle made of triangles here. How many triangles do you see in that triangle, ladies and gentlemen? 4. There's last period actually even did more. I think they added more triangles at the bottom. They did a longer one, which is fine. Do I have somebody that wants to do the rhombus now? A rhombus made of rhombuses. You want to come up or you want to explain it to me? Okay, go.
So I just draw like that?
Yeah.
Okay.
There's your rhombus. There you go. So this rhombus is made up of 4 different rhombus. Is it rhombuses or rhombi? I don't know the plural for rhombus. So there's 4 different rhombuses. I don't know. You're switching up the word now. So there's 4 different ones in that shape. Okay. And then the trapezoid was a little bit trickier. Did anybody figure it out? You figured it out? Let me see your drawing first. Let me see your drawing first. Because I'm going to tell you, there's one that I have to still look at the book, and I still can't draw it appropriately. Yeah, I got to look at the teacher's edition, because I can't do it. But there's one that's super easy. Let me see. Nope, because you didn't use the classic. Okay, remember, the classic one is like that, right? Technically, you can make a trapezoid by doing this. Those are 2 different trapezoids, but that's not what you're supposed to do. Again, you were supposed to use the classic version. If you see, this is not the classic trapezoid, right? The classic trapezoid you were supposed to use should look like this. So how do I put this inside of here and make it into a trapezoid? So, all right, come up. You just want me to leave it like that and you can highlight in there? All right, Mikey's going to come up and try it. Yeah. Well, that's already a trapezoid. What do you mean? All right, come up. I think I know what you mean. Come up. I know what you mean. You're just going to add 1 more? Or 2 more? You going to add 1 more or 2 more? Just realize the mic is recording, right? So whoever was singing off key, definitely signing you guys up. No. Gonna be signing you up for choir now. Just let them know you need to change your, definitely need to change your elective. Okay, so, you got it? If I leave it like this, you can draw it inside? Alright, hang on. We got someone coming up. I gotta find that page because... Bring your notebook if you need to. Go for it. There's the pen.
God. Ooh, that looks bad.
Hang on.
It's horrible.
There you go. Okay, technically you're right, but technically those aren't the same. So we were talking about what earlier? We're talking about congruent, right?
Yes.
Okay, I messed up and didn't tell you that all the shapes need to be congruent. Technically you're right. That's a trapezoid on top of another trapezoid, and that works. Okay, let me find the page in here, and I'm going to show you guys. Okay? Because I know I saw it in here, and I'm going to do the best that I can to draw it. There it is. Why?
I don't know.
Okay, here is the difficult one that the textbook gives us. Okay, I gotta be very careful with this because it's hard to tell. So there's 4 trapezoids. It's not drawn perfectly to scale, but there's 4 trapezoids inside of it. Shh, guys. Now, the other way to do this would be this way. And this is the one that I said don't think too hard about. Those are 3 trapezoids next to each other. The one in the middle is flipped upside down. But if I were to draw the actual shape on the outside, it's a trapezoid. So, this trapezoid made up of 3 different trapezoids in a straight line. This is why I said don't overthink it. The other one that I drew earlier, yeah, that one definitely even I couldn't do. And heck, they did the same one and then they put a trapezoid on the top of it to make another trapezoid, which is crazy. So, yeah, let me rewind. Yeah, then they did this. And they put another one on top of it. So, technically, it's still a trapezoid. So, basically what you guys did right now is you learned how to manipulate shapes, okay? We've talked about congruency. We're talking about manipulating shapes. But now what we're going to be doing is this. You've got 3 shapes here. This is an individual activity, not a group activity. This is a wonder and notice, or as the book puts it, notice and wonder, because I have dyslexia. So, what do you notice about these shapes? What do you wonder about these shapes? Think to yourself, and then I'm going to call volunteers. So, what do you notice and wonder about each of those shapes? So, remember, a notice is, this is what I see. This is what I'm looking at, and I notice this, or this. Wonder is a question you're asking yourself. So do you have a notice or a wonder? You can put this in your notes. You should probably put this in your notes. But what do you have? Do you have a notice or a wonder? What do you notice about these 3 shapes?
If you were to flip figure A and figure B, it would be congruent. Is that how you say it? Congruent as figures.
How would you flip it? Okay, I know what you're talking about. So basically, let's start with figure B. I would flip it up on its side and then flip it around again, right? So that corner would match. So, okay. So they'd be pretty. So basically, figure A and figure B are in the same orientation. That's the vocab word we're going to learn. You may want to put that in your notes. Figure A and figure B are in the same orientation, where figure C is not. Okay? Think of figure A and figure B as a piece of binder paper that's on its side. Holes are on the top. Okay? This one's bigger than that one. It's scaled differently. Whereas figure C, this is the back of the page, and it's right side up. Okay? So these two, this is the front of the page. Holes are right here, so it's on its side. This one is right side up, but we're looking at the back of the page instead because it's flipped. Because if I were to flip this one over to the front, now they're in the same corner, right? They're just in different orientations. What else do you guys notice and wonder? There's no right or wrong answers. There's simple ones. What do you guys notice? Yes.
They all have 3 corners cut off.
Okay. So they all have one of the corners cut off, which means 3 of these corners are all what? 90 degrees, and they are missing their 4th one because of that weird corner that's cut, right? Anything else that we have? Notice or wonder? Quiet hands up. No other notice or wonder? They're all the same shape, different areas. Okay, there you go. So, basically what we're doing here is this. What we're talking about with this lesson is scaling shapes, okay? So I'm going to go off script on this. I'm going to go do some of my stuff that I want to do. So for example, you guys ever hear something drawn to scale or made to scale, like a replica? Like if somebody buys like for example, a Statue of Liberty, all the proportions are drawn the same, but it's like 1/64 or 1/1000th the shape of what it normally is, right? So basically, if I were to blow up the Statue of Liberty 1,000 times, it would actually be the exact same size and shape as the regular Statue of Liberty. You guys have heard that? Something drawn to scale? So, for example, I have a square, okay? Let's say the sides are 3 each, right? 3 inches each. If I wanted to draw another square that was to scale, which means a bigger square, but that could easily become that square, or the other square could become it, those sides would need to be what? What length would I need to pick for the side of that square to make it something that it could become that, so I could scale it into it? 6 was one of them. So if I make this side 6, this square is now drawn to scale, right? Let's call this square A and square B. Talk to your groups. What's the relationship between square A and square B? Go.
They both have
They're both squares, technically. But what's the relationship between the two? We're looking at the side lengths. What's the relationship? Mikey got it. Okay, now reverse it. If one is what you said, I don't want to say it out loud because I don't want to give the answer away. What you said, now reverse it. What's the other one's relationship? So if I say, okay, now flip it. The other one is what? What's another way of saying that? A word. One word. Did you say? What did you say? There you go. That's the word I was looking for. I didn't hear that the first time. Maybe I did. So eyes are up here. Ladies and gentlemen, square A and square B have a relationship with each other because they are scaled. Okay? The scaling deals with the size that each of them are. Both of them are squares, but A has a length. Each length is 3 inches, while B's length is all 6 inches. So what's the relationship? If I say square A is this to square B, what's the word I'm looking for? What is square A to square B?
bigger.
Square A is bigger than square B?
No, smaller.
Smaller, but now let's be specific. It's half. Because this length is 6, this length is 3. Now, let me be more specific, okay? Because technically, we can get super deep into this. What's the area of square B if one side is 6? It's 36 inches squared. What's the area of square A? if one side's 3. Okay, now, I kind of let you guys fail on your own for a second. Is 9 half of 36? So, the square itself, this is where we have to be very careful with the words we use. The square itself is not half or double. It's the lengths. Okay? We drew to scale. We're going to ignore that for just to finish this lesson. So, the squares are drawn to scale. They are drawn to scale. The size is not. Okay, so I can't say square A is half of square B because it's not. 9 is not half of 36. But the lengths, the scale is. Square A has a length of 3, while square B has a length of 6. So we doubled the scale of that. Now, is everything going to match appropriately? No. That's like me trying to make the Statue of Liberty and do half of the Statue of Liberty. Is when I put it together, is the arm going to be half the length of the arm? Is the head going to be half the size? Like, it's not. But you guys need to understand this is what scaling does. So basically, think of it this way. If I were to grab this, if this frame here were like a picture in editor and Canva, whatever, if I were to make it bigger, it would eventually fit here perfectly. That's called scaling. Okay, if this square had a length of like 4.5, now it probably wouldn't scale perfectly, would it? It wouldn't, because 3 cannot become 4.5 evenly. I mean, it probably could. We'd have to multiply it by some weird fraction, but it probably won't. So that's what we're dealing with this lesson. We're scaling shapes up and down, making them bigger, smaller, but keeping their shape the same. Understood? Okay, so we're going to go ahead and end the video here.